Hello, my name is Kriti Bharti. I'm a senior product manager with Amazon Web Services focusing on Internet of Things. I have been with AWS for 2 years now, and I'm excited to speak with you today about the AWS IoT Device Defender product. In this webinar, we will discuss AWS IoT Device Defender, a recently launched IoT security service. The webinar will include a product overview as well as feature description, use cases, architectural overview, and finally a demonstration of the product in use. Let us start with an introduction of AWS Internet of Things services. AWS IoT has a suite of services from the edge to the cloud that help our customers manage their IoT workloads effectively and efficiently. Amazon FreeRTOS and AWS Greengrass are our edge-based softwares that allow customers to securely connect their assets, gather data, and take intelligent actions locally, even when internet connectivity is down. Among the cloud-based services, we offer AWS IoT Core, AWS IoT Device Management, AWS IoT Device Defender, and AWS IoT Analytics. AWS IoT Core enables our customers to securely connect devices to the AWS cloud and other devices and to route, process, and act upon data from these devices. AWS IoT Device Management helps our customers to quickly and easily onboard and manage their large and diverse device fleets. Customers use AWS Analytics to reason on top of their IoT data. At the AWS Summit in Chicago this year, we announced general availability of AWS IoT Device Defender, a fully managed IoT security service that will help customers keep their fleets secure. Security is and always has been a top priority at AWS. Our customers connect their devices securely to AWS IoT using security mechanisms that are well known, well understood, and well vetted. For example, we support X509 certificates, a standard way for managing identity. We recommend using TLS 1.2 protocol for encryption. However, the analysts and industry experts still call out IoT security as the #1 adoption blocker among enterprises for IoT technology. IoT security is what keeps our customers up at night. The challenge with IoT security is that IoT devices are not designed with security in mind. The large size of IoT device fleets present a huge attack surface and also makes it difficult to find problematic devices, almost like finding a needle in a haystack. Additionally, these devices are deployed in diverse, untrusted environments that are hard to control and sometimes hard to access. Therefore, pushing a security patch to these devices is not easy or straightforward. The goal of AWS IoT Device Defender is to help our customers address the difficult challenge of how to keep their connected devices secure. The fact is, the devices can be compromised because security is not point in time. It is important to understand that the fact that a device is secure today does not guarantee that it will be secured tomorrow. So what is it that our customers really need? Our customers need a mechanism that can detect a compromise. When compromises do take place, customers need to receive notifications that alert them to the fact that the devices have been compromised. Lastly, customers want assurance that whichever system that they are using for their IoT security needs can evolve to address the always evolving threat landscape. In order to understand the benefits of AWS IoT Device Defender, you have to first understand what customers want and need. When we talk to customers to get a better understanding of what is it that they need from an IoT security service, the first thing that many customers mentioned is that they need their IoT configurations to be secure. The #1 cause for security compromises happening in any system is insecure configurations. We all know that the Mirai botnet exploited the default user ID and password combination of simple IoT devices such as CCTV cameras in baby monitors to launch a DDoS attack. Insecure configuration is a leading cause for security incidents. So IoT Device Defender provides a feature to identify any violation of security best practices in IoT configurations. Similarly, IoT devices are usually single purpose devices with well understood behavior. Any deviation from expected behavior is a reason to investigate. If the devices start behaving in a way that is unexpected, the customers need to be informed about these anomalies, as this is likely a cause for concern. The third thing that the customers told us is that they want to receive alerts in a way that works with their existing systems. Customers are already using SIEM systems such as Splunk or CloudWatch, and they want to make sure that they don't have to come up with or adopt a new system to use a new security service. Most importantly, customers want enough information to be able to investigate the issues and take the necessary mitigating actions in a timely fashion. AWS IoT Device Defender helps our customers meet all their security objectives. AWS IoT Device Defender continuously monitors our customers' IoT devices and the associated resources, including how they're configured and how they're behaving, and sends near real-time alerts to our customers when a security gap is identified. Device Defender is a fully managed service that will help customers audit their device fleets, detect any abnormal device behavior, alert them about identified security issues, and then helps them investigate and mitigate the security issue. Let us dive deeper into each feature now. The first feature that we will discuss is Audit. Audit helps customers audit the resources related to their IoT devices to ensure that they are configured securely. Customers can enable a set of standard audit checks that act on various resources such as device certificates, IoT policies, etc. These checks are mapped to recommended security best practices for AWS IoT, such as not using X509 certificates which have been revoked by its certificate authority. Customers can also configure the frequency at which they want to run their audits. They can either choose a periodic frequency of daily, weekly, bi-weekly, or monthly audits, or run ad hoc reports as per their needs. Let us say that the customers have a deployment that has happened in production and they want to make sure that this has not adversely affected the configuration of their IoT resources. In such a case, they can schedule an on-demand audit. The checks that we have currently available act on certificates, policies, device connection, and account settings. For certificates, we will check if the customers are using any expiring or revoked X509 certificates or CA certificate. A CA certificate may have been revoked because it was compromised, and newly added devices with certificates signed using the CA certificate would pose a security threat. Similarly, a device certificate is usually revoked because it has been compromised. It is possible that it has not yet been revoked in AWS IoT due to an error or an oversight. IoT Device Defender also checks for certificates that are within 30 days of expiration. Expired CA or device certificates may potentially not have their private key protected as well as an active certificate. We will also look for devices having multiple concurrent connections to AWS IoT using the same X509 certificates for identity management. When multiple devices use the same certificate, this may indicate that the device has been compromised and its identity cloned in order to further compromise the system. It may also indicate an error when provisioning a fleet of devices, causing accidental provisioning of multiple devices with the same certificate. In scenarios where a certificate is intentionally provisioned to multiple devices, this could indicate an associated overly permissive policy allowing all corresponding devices the same level of access. An adversary could exploit the certificate to emit malicious data on behalf of other devices and or gain unwanted access to data published by other devices. Audit will also flag any overly permissive IoT policies. For example, if a device has permission to publish to all topics, or if the device has permission to perform any administrative action like deleting the IoT resources associated with other devices. Those are the kind of things that we will be able to catch with overly permissive policies. A certificate, Cognito ID, or think group with an overly permissive policy can, if compromised, impact the security of your entire account. An attacker could use such broad access to read or modify device shadows, jobs, or job executions of all your devices. Or the attacker could use a compromised certificate to connect malicious devices or launch a DDoS attack on your network. Similarly, we will identify Cognito IDs that have overly permissive access. If an authenticated Cognito identity is compromised, it could use administrative actions to modify account setting, delete resources, or gain access to sensitive data. Since unauthenticated identities are never authenticated by the user, they pose a much greater risk than authenticated Cognito identities. If an unauthenticated identity is compromised, it could also use administrative actions to modify account settings, delete resources, or gain access to sensitive data. Or, with broad access to device settings, it could access or modify shadows and jobs for all the devices in the account. A guest user might use the permissions to compromise the entire fleet or launch a DDoS attack with messages. We also check to see if multiple MQTT connections are simultaneously using the same client ID. Per MQTT specification, devices with conflicting IDs are forced to constantly reconnect, which may result in lost messages or leave a device unable to connect. This may indicate the device or device's credentials have been compromised. It is also possible that devices are misconfigured in the account or a device has a bad connection and is forced to reconnect several times per minute. Lastly, we will check if customers have enabled logging for IoT Core to ensure that they are able to receive all the logs if they want to investigate any issues. AWS IoT provides logs for keeping customers informed of interactions in their account. This includes authentication failures or unexpected connects and disconnects that may indicate that the device has been compromised. AWS IoT Device Defender also has a feature called Detect to continuously monitor high-value security metrics associated with the device, such as the IP addresses that the device is communicating with. Customers can use Device Defender to monitor both cloud-side as well as device-side security metrics. Customers define the expected behaviors or rules associated with these metrics and receive an alert if their devices violate the defined behavior. Customers can define expected behavior or rules for these security metrics either in the IoT management console or using our APIs. Customers can define two different kinds of behavior rules. The first is a blacklist or whitelist behavior. For example, a port number or an IP address that they would like to blacklist or whitelist. Customers can also define behaviors to establish threshold for different metrics, such as the number of outgoing bytes over a configurable unit of time. The blacklist whitelist behaviors are evaluated as soon as the data is received by AWS IoT Device Defender, and the customers are alerted if there are any violations. The threshold behaviors are aggregated over the time period that has been configured by the customers, and they receive an alert if the aggregated behavior violated the expected threshold. Customers can use Device Defender to monitor both cloud-side as well as device-side security metrics. Customers define the expected behaviors or rules associated with these metrics and receive an alert if their devices violate the defined behavior. Customers can define expected behavior or rules for these metrics either in the IoT management console or using our APIs. Customers can define two different kinds of behavior rules. The first is a blacklist or whitelist behavior. So a port number or an IP address that they would like to blacklist or whitelist. Customers can also define behaviors to establish threshold for different metrics, such as the number of outgoing bytes over a configurable unit of time. The blacklist whitelist behaviors are evaluated as soon as the data is received by AWS IoT Device Defender, and the customers are alerted if there are any violations. The metrics for the threshold behaviors are aggregated over the time period that has been configured by the customers, and customers receive an alert if the aggregated metric data points violate the expected thresholds. The cloud-side metrics are event-driven and are captured by IoT Device Defender whenever there is an activity associated with customers' devices on IoT Core. The device-side metric need to be published to the IoT Device Defender topic in MQTT in a predetermined format and a configurable frequency. The format that we support is either JSON or CBOR. The frequency is configurable by the customers. We recommend a reporting frequency of every 5 minutes to capture all device-side activity. We will provide customers with reference implementation code that they can customize according to their use case. A collection of expected behaviors is called a security profile that customers can associate with a group of devices or for all the devices in their AWS account. This makes it easy for customers to manage the expected behavior of their IoT devices since they don't need to define behavior for individual devices. A security profile can be attached to a thing group. A thing group is a logical group of devices that can be arranged in a hierarchy going 7 levels deep. Expected behaviors defined in a security profile that is attached to a thing group is inherited by all the devices in that group's hierarchy. A security profile attached to the customer's AWS account applies to all the devices in their account. In our example on the screen, if the customer was to attach a security profile to the thing group floor, it is going to be inherited by all the 3 devices over here. Similarly, whenever security profile is attached to the thing group category, it would be inherited by all the devices under that thing group. If there are multiple behaviors for a device, because it is a part of different thing groups, then IoT Device Defender will conservatively or across all the different behavior rules. Therefore, if one behavior says whitelist IP address 1.2.3.4 and the other one says blacklist IP address 1.2.3.4, the customer would be alerted every time that the device communicates with IP address 1.2.3.4 since we monitor for either behavior violation. The security metrics that we are collecting from the cloud includes a message rate for both sent and received messages, message size, authorization failure, and source IP address. Elevated message rates can indicate a device is compromised and attempting to perform denial of service against a customer's account or malicious use of resources. Elevated messages due to a compromised device also results in the increased cost for customer. Increased message size can indicate a device attempting a denial of service or malicious use of resources, such as driving up the cost for the customers, injection of invalid sensor data, or exfiltration of customer data. Large number of authorization failures can indicate compromised devices enumerating their granted privileges to identify horizontal and or vertical privilege escalation paths to exploit other devices and resources in the customer's account. Monitoring source IP helps customers who have their devices communicating from known network subnets to be alerted if any device outside that subnet communicates with AWS IoT. Similarly, this also allows monitoring blacklisted subnets from which customers never expect any traffic to be sent to AWS IoT. On the device side, customers can monitor destination IPs, TCP connections, open ports, inbound and outbound packets, and bytes. Connecting to untrusted or unknown IP addresses can indicate that your device has been compromised and a remote attacker has established a command and control channel with your device, or that device is performing reconnaissance or attacks against a third party. The connections to unexpected destinations may also indicate a compromised device abused as a network traffic anonymization node, cryptocurrency mining worker, or email spam campaign node. An elevated number of outbound TCP connections could indicate that the device is being used as part of a DDoS attack, network traffic anonymization node, or email spam worker. An elevated number of inbound TCP connections could indicate the device is exposed directly or indirectly to public internet and hence under mass internet-wide scans. Alternatively, this inbound TCP connection elevation can be due to a compromised local device within the device's local network performing local reconnaissance. Depending upon the elevation level, the unusual TCP connections may indicate additional connection to a command and control server communicating with the compromised device. Monitoring open ports on a device helps ensure no unexpected ports are open on the device with malicious identities could exploit for gaining access to the device to possibly install a malware. Unexpected open ports can also indicate a compromised device which is listening for command and control messages from a report attacker. Furthermore, adversaries who have compromised a device could have installed or launch utility software for facilitating the infiltration and persistence with side effects of opening service ports on the device. Expected open ports, which are reported as closed on a device, could indicate a malware attempting to either block other malwares infiltrating the compromised device or disable administrative communication channels used for removal of malware. Elevated rate of incoming and outgoing bytes or packets could be an indicator of the device participating in adversarial activities such as reconnaissance and infiltration of other devices, as well as abuse scenarios such as DDoS attacks, mining cryptocurrency, network traffic anonymization, sending out spam emails, or data exfiltration using device sensors. Depending upon the level of elevation and its patterns, incoming bytes and or packets may also indicate that the device might be a target of DDoS attack or an attempt to install malware. The next feature we will discuss is alerts. To make sure that our service works with existing systems that the customers may be using, we send customers alerts for both Audit and Detect to Amazon CloudWatch and Amazon SNS, in addition to the AWS IoT console. CloudWatch gives us the freedom to provide an alert mechanism for our customers that allow them to continue to use their existing SIEM systems. As an example, Splunk is integrated with CloudWatch logs. Similarly, customers can use Amazon SNS to configure Lambda functions that can automate certain actions that the customers might want to take. By design, we don't take any canned responses on behalf of the customers because we don't want to inadvertently take an action that may cause the customer's production fleet to be down for any length of time. But if the customers desire, they can configure a Lambda function and take automated action based on the information that they have received. Amazon SNS also gives customers the flexibility to integrate IoT Device Defender with their device management solutions. The final feature we will discuss is Mitigate. AWS IoT Device Defender provides contextual information, historical information, and recommendations that will help our customers investigate the possible issues. For example, if the audit violation is about devices sharing X509 certificates, customers will get the certificate ID, device ID, as well as recommendation on the necessary steps required to fix the issue. For Detect, customers will be able to view the times the device has violated the defined behavior, as well as if and when the device has moved out of violation and into compliance with the defined behavior. The default time period that the customers detect metric data is available for is 2 weeks. To mitigate the issues, customers can leverage the device jobs feature of AWS IoT Device Management to take remote actions on their devices, such as rebooting a device or resetting it to factory default settings or pushing a security firmware update. Customers also have the flexibility to choose another device management solution of their choice, and as previously mentioned, automate their response using AWS Lambda. Let us now look at how IoT Device Defender works. The way it all comes together is that the device samples the metrics they want to report at a pre-configured frequency, such as every 5 minutes or every 1 hour, and publish it to the reserved IoT Device Defender topic in MQTT. The whole pipeline of AWS IoT Core works just as if the customers were reporting their own telemetry data. We provide customers sample code to aid them in their implementation. Additionally, AWS Greengrass and Amazon FreeRTOS are fully integrated with IoT Device Defender to provide an effortless implementation to publish the Device Defender metrics. So, if the Amazon FreeRTOS or Greengrass customers choose to use the AWS IoT Device Defender service, all they would need to do is to go to our IoT management console or use our APIs to configure the behaviors, and there are already bits on the devices that they would be able to start reporting the device metrics immediately. IoT Device Defender also collects metrics from the AWS IoT Core, which are associated with device activity. Once these metrics are received, the relevant data is extracted and used by AWS IoT Device Defender. Once the data is extracted, we analyze it. For audit, we match the configuration against the recommended security best practices. For detect, we match the metric data points against the user-defined device behavior, and any deviation or any issue that we identify is published to IoT Console, Amazon CloudWatch, and Amazon SNS. Then the customers have the option to use AWS IoT Device Management to take necessary actions. However, they can also use their own device management tools, either one that they have built in-house or any third-party systems that they are using to take mitigating actions. Let me show you how easy it is to get started with AWS IoT Device Defender. Customers can start using audits with just a few clicks in the AWS IoT console. Navigate to the Defend menu in the left nav bar and click on Audit. You can see all the audits you have set up by clicking on Schedules. As you can see, I already have a couple of recurring audits set up already. I'm going to start a new audit and click on the Create button. This will bring up a list of all the audit checks that are available to me. I select the audit check I want, in this case, a check for a revoked certificate still enabled. I then select how often I want to run this audit. You can select the desired frequency from the drop-down menu. I choose to run the audit now. I can see the progress of the audit in the Results tab. I can click on the audit name to see the details. When the audit completes, I can dive deep into the audit check to see the details of the non-compliant resources, as well as the recommendations on how to fix those. As you can see, I have 7 non-compliant certificates. When I click on the certificate, I'm taken to the certificate menu where I can take the necessary action to revoke the certificate or deactivate it. When I run the audit again, the number of non-compliant certificates will now reduce to 6 since we already deactivated one of the non-compliant certificates. Audit is as simple as that. To get started with Detect, navigate to the Defend menu in the left nav bar and click on Detect. This will bring up the Detect submenu. Click on Security Profiles to manage your security profiles. For the purpose of our demo, I'm going to create a new security profile called Test Now. I will define a behavior for the number of messages sent, since unexpected volume of messages could be indicative of device compromise. Keep in mind that the behavior you define is the expected behavior for the device, and you will receive an alert only if this behavior is violated. So in this case, IoT Device Defender will send me an alert if any of my devices send more than 3 messages every 5 minutes. On the next screen, I have an option to select the SNS topic I want this alert to be sent to. I can either select an existing topic or create a new topic. I will also need to give IoT Device Defender permission to publish on that topic I have selected. IoT Device Defender will send the alert to both the SNS topic as well as the IoT console. In the next screen, I specify whether I want to attach the security profile and all the behaviors it contains to a specific group of devices or all the devices in my account. Once I click Save, IoT Device Defender will start monitoring the message sent metrics for all my devices and alert me if the number of sent messages exceed 3 in 5 minutes. I'm now going to run a script to simulate that 3 of my devices are sending 6 messages every 5 minutes. IoT Device Defender will alert me near real time whenever it detects that my devices are violating the expected behaviors. I can view the current alert details in the violation menu of Detect. I can also navigate to the historical view to investigate when and how often the device violates the defined behavior, and also when it moves out of violation and into compliance with the device behavior. In summary, using AWS IoT Device Defenders, customers would be able to schedule or execute on-demand audits for certificates, policies, and devices, continuously monitor the device behavior through high-value security metrics and identify anomalies, receive alert on console, SNS, and CloudWatch with enough information to investigate and mitigate the issues. Thank you. Please feel free to reach out to us with any questions at the email address on your screens or post your query on IoT Device Defender forum.